All right, so tonight we're going to be looking at some trig identities. So we've done graphing, we've done your basic sine, cosine, tangent. You've done all of that before. So what we're doing today and throughout this unit is we're going to be looking at these different identities that come up with trigonometry. And we're going to need to know these identities to be able to help us simplify algebraic expressions that have trig in it. So some of the first ones we've actually already done. They're called reciprocal identities. And that would be how cosecant is equal to 1 over sine. It's equal to the reciprocal of something else. That would make it a reciprocal identity. Now that goes with sine of x would equal the reciprocal of cosecant. So these are both reciprocal identities. We also have secant of x is going to equal 1 over cosine, and then again cosine of x would be 1 over secant of x. And then we also have our cotangent, which is the same as 1 over tangent, which we can also write tangent of x is equal to 1 over cotangent of x. There's one other, it's not really it's kind of a reciprocal, but it's just to make sure you also remember that tangent of x is sine x over cosine x. So that means when we do cotangent, it's the reciprocal of that, cosine x over sine x. So these are just properties or identities that you would need to know. Most of us already know these because we went over them in the last unit, but you might need a little bit of refreshing. Okay, the other ones, and I can't remember if you learned these in Math 3 or not. I think you did, but if not, that's okay. And that is our Pythagorean identities. So we have 3 Pythagorean identities. And how do we get them is based on our unit circle. So if we draw our theta, we know that our hypotenuse is 1 because it's a unit circle, and that our y is our sine and x is our cosine, or we have x and y, whatever those are. Together they help us make our unit circle. So these are all things we know just based on what our unit circle is, and the radius is equal to 1. And so what we're going to do is figure out some different things, all based on these 3 things that we know from our unit circle. So the first thing we know about the Pythagorean theorem is that x squared plus y squared equals 1. So that means if we were to do just a basic substitution, cosine for x, sine for y, sine squared theta plus cosine squared theta would equal 1. This right here is our first trig identity. And it just comes from substituting in what we know cosine and sine equal in terms of x and y. Now, one of the things you want to also be aware of is that we can change the way this looks. So if we were to solve for sine squared, that would be 1 minus cosine squared. These are the same identity, just solved for something different. You can also solve for cosine squared, which would be 1 minus sine squared. So again, these two are just rewritten forms of this one trig identity. Okay, so like we have 3 total. So how do we get the next one? If we were to take our original sine squared plus cosine squared equals 1, and divide everything by sine squared theta. What would we get? So sine squared divided by sine squared would equal 1. Cosine over sine, that's cotangent. And then 1 over sine is cosecant. And these shall be squared. This is our next Pythagorean identity. Okay, so if you have 1 plus cotangent squared equals cosecant squared, you have another identity. And then just like in the other one, if we were to solve for cotangent, that would be cosecant squared minus 1, or even get the two terms on the same side. It would be cosecant squared theta minus cotangent squared theta equals 1. So these are, again, just two other ways that we can rewrite this one identity that we have. Okay, now for the last one, we're going to go back to what we had in our first trig identity, sine squared plus cosine squared equals 1. And we're going to look at what happens now when we divide everything by cosine squared theta. So when we divide everything by cosine squared, sine over cosine is tangent. Cosine over cosine is 1. And 1 over cosine is secant. So this here is our third trig identity. And just like the others, we can write it in its different formats. So we can do secant squared theta minus tangent squared theta equals 1. That would be if we moved the tangent over and got them on the same side. Or if we solved for tangent squared, we would get secant squared theta minus 1. Really, if you just know these three, the rest are just manipulations of those three identities. So what we're going to be looking at today in some of our, or tonight in some of our examples, and we'll do more tomorrow in class, is we're going to be looking at how can we use these three identities plus the reciprocal identities to simplify algebraic expressions with these trig functions. So we're going to do 5 here and 5 more in class to make sure you guys are okay with this whole idea of simplifying. So our directions are just to simplify. So our first one is how can we simplify 1 over cosecant x? Well, that's one of our reciprocal identities. So how can that be simplified? By just setting it equal to its reciprocal identity. How to know when you're done simplifying is you should have as few trig functions as possible. And when you can't combine them or make it any less than what you have, that's when you know you're done. Okay, our second one, cosine x times secant x. So again, we're going to start by rewriting using our identities so that we can try to simplify. So cosine, I can't really simplify that, or I can't think of a thing. But secant I know is 1 over cosine. So if I think of this as two fractions being multiplied, cosine x times 1 is cosine x, 1 times cosine x is cosine x. When you have the same thing on top and bottom, it simplifies to 1. If you wanted, you could cross cancel as well, depending on your comfort level with cross canceling. Okay, the third one I wanted to do with you is secant squared x minus 1. What does that equal? So this is where we want to think about our identities and if we can get it to match one of them. So this is actually one, if we look at the identity, 1 plus tangent squared theta equals secant squared theta. If we were to solve for tangent squared, it equals secant squared theta minus 1, which is exactly what we have. So then I can say that this is going to equal tangent squared theta, and that would be your simplified answer. So again, if you don't remember all the different formats that these trig identities can be in, go ahead and just start with the one of the three and see if you can solve it, so that way it's less that you have to memorize. Okay, the next one, we're going to kind of kick it up a notch a little bit. Cosecant x times the square root of 1 minus cosine squared x. So again, in our heads, we should be looking at, or in our notes, we should go back to our identities that we just did to see, can I do any sort of substitution with any of my identities? So when I look at the notes, I notice that I had sine squared plus cosine squared equals 1. Well, if I solve for sine, I'll subtract cosine to both sides, and I end up with what I have right here. So that means I can substitute, so I'm going to change this to 1 over sine, it's reciprocal, and I can substitute in here sine squared x. So then, what's the square root of sine squared? Well, that's going to follow our same rules as before. So the square root of something squared is that something. And this is over 1. So again, we can multiply across the top, multiply across the bottom. They cancel out, and your answer would just be 1. Okay, there's one more I wanted to do with you tonight, and then we'll do 5 more tomorrow. And this last one is 1 minus sine squared x over cosecant squared x minus 1. So again, one of the first things I want to do is look for either a reciprocal identity or a trig identity that I could potentially use. So when I'm looking at this, I notice I have a sine squared and a cosine squared, or sorry, a sine squared and a cosecant squared. Well, I have some identities with sine squared as well as cosecant squared. So I'm going to look at and think cosine squared plus sine squared equals 1. So if I solve for cosine, so I forgot my x's, then I'll get 1 minus sine squared x, which is what I have here. So that means on top I'm going to have a cosine squared x. On bottom, I know I have a trig identity that contains a cosecant, and so my trig identity with a cosecant says cosecant squared x equals cotangent squared x plus 1. So this is the identity, but if I solve for cotangent by moving the 1 over, I get my cosecant squared x minus 1, and I know that it's going to equal cotangent x. cotangent squared x, sorry. So by just looking at the two identities, I can rewrite that fraction as cosine squared over cotangent squared. But we're not quite done because we still want to look to see, can I get even fewer than two trig functions in my answer? So now I'm going to think about, what does cosine squared divided by cotangent squared really mean? Well, that means cosine squared x times, and now I can think of 1 divided by cotangent squared x. Well, that can become cosine squared x times 1 over cotangent, that's a reciprocal. That's going to equal tangent squared x. And well, if we look at what tangent squared equals, and this is where it's sometimes helpful to break the tangent apart into sine over cosine. Oops, I keep writing like theta, and I mean x. So we can rewrite this as sine squared x over cosine squared x. And now we have a fraction that we can multiply and simplify. So cosine squared will cross cancel with cosine squared, giving us a final answer of sine squared x. Okay, this is kind of what most of your problems are going to look like. The first 4 were a little more basic, where we only had 1 substitution and we were pretty much done. Here we had 2 substitutions, and then we had some simplifying to do, where we had to use reciprocal identities to help us out. So here's where we're going to end for tonight, but tomorrow we have 5 more that I want to do. Some that are like another one like number 5 here, and then some where we're actually going to look at numerical values to see how we do it when there's numbers in there, and then actually 2 more like 5. 2 more like 5 and 3 with numbers in there. So any questions you have, make sure you note them so we can go over them in class tomorrow. Or if you want, you can send me your questions and I'll have them ready to go when we start our class.